Hello everybody, welcome to our lesson today on using the tangent ratio to calculate triangle length. So let's hop right into it. Just before we begin, just a quick reminder of what we learned in chapter 2.1. Right? So the tangent of a given angle, so in this case, we're looking at angle A here of this triangle. The tangent of this angle is the side that's opposite to it over the side that is adjacent to it. Right? So it is a ratio or a fraction of the side length furthest away from the angle over the side that is right next to the angle. So opposite side to the angle A over the adjacent side, right? Or the side right next to angle A. To angle A. So in this particular triangle, we have the side BC over the side AC. Right? And of course, just a general rule of thumb, all angles of a triangle will add up to 180 no matter what. This is always going to be a rule. And lastly, tangent only works for right triangles. Alright, so with the reminders out of the way, how can we find the side length of a triangle given one angle and one side length? Right. Unfortunately, the Pythagorean theorem can only carry us so far. So let's take this example here. We want the length of AB, so it's this length right here. Right? So once again, if we have two letters side by side in math, that usually means the line between point A to point B. So the line AB is just this line right here. We want the nearest tenth of a centimeter. Okay, so from what we learned about tangent, we know it is the opposite side of adjacent side. So in this case, we will be looking at this angle right here. So angle C. Just by looking at this, we know the tangent of C is AB over BC, right? So the tangent of C right here is this opposite side over this adjacent side. So the opposite side, AB, is what we want to find over 10 centimeters. And from the triangle here, we see that C has an angle of 30, right? Which means that the tangent of 30 degrees equals to the side length AB over 10. Right? And from there, it is just a simple algebra question. We are solving for AB, which is the unknown in this case. Right? To do that, we will multiply both sides by 10 to isolate the AB. Right? This gets us 10 times the tangent of 30 degrees equals to AB. And from here, all we have to do is plug into a calculator. Right? So this is gotta be careful here. We're working with degrees here, so make sure your calculator is in degrees mode. Right? So we have 10 times the tangent of 30. All right, that gets us 5.8 rounded centimeters. So we know the side length of AB here is 5.8 centimeters, even though I didn't really draw like it. However, if our answer was negative, or let's do a different color. If your answer was negative 64.1, right, that means you have accidentally done a question in radians mode, right? So this is what you would get if you typed in radians, which obviously not possible to have a negative side length, right? So always make sure your calculator is in degree mode or your calculator follows the question. All right, let's try a few more here. So in this example, we have to find the length of EF. Right? So let's actually highlight it this time. The length of EF refers to this length right here. So once again, using what we know, the tangent of F is the opposite over the hypotenuse. Nope, just kidding, not yet. Is the opposite over the adjacent. So in this case, the side opposite, right? So in this case, the side opposite to this angle F is ED, and the side adjacent to this angle F is EF. So the tangent F is ED, or let's do DE here, so it's alphabetical, DE over EF, which is 3.5 over EF. Right? EF is the unknown. We also know that the tangent of f is just a tangent of 20 degrees. Right? So we know tangent of 20 degrees is equal to 3.5 over EF. So from here, once again, back to basic algebra. So we multiply both sides by EF to get rid of the fractions, because as mathematicians, we do not like fractions. We have EF times tangent of 20 equals to 3.5. And now to isolate the EF, we divide both sides by tangent of 20 degrees. We have EF equals to 3.5 divided by tangent of 20 degrees. And all that's left is to plug into a calculator, of course in degrees mode. So 3.5 divided by tangent of 20, we get 9.6 centimeters. Right? And that's our answer. 9.6 centimeters right here. So yeah, the whole premise of finding the side length using tangent is figuring out what is the unknown and then solving it just like a basic algebra equation. Alright, so now let's do a word problem here. Searchlight beam shines vertically on a cloud. Right, so let's draw a nice cloud here. We have a searchlight at the very bottom, so something like that. So this line, this light rather. Alright, so this is light right here is shining directly into the cloud. And at 250 meters from the light, the angle between the line of sight to the ground is 75 degrees. Right, so let's say we are right here. We are currently 250 meters away from the light. And our line of sight, so from what we see to this light right here, is 75 degrees. So now we have to find what is the length of this light beam to calculate the height of the cloud. Right, so this question can just boil down to this triangle right here. It's a very small triangle. Should have made it bigger. Okay, so we have 250 meters right here, and we have 75 degrees right here. We want to find out what x is right here. So as we can see right away, all we have to do is use what we learned earlier. Right? So we have the tangent of 75 degrees. Right? So we're looking at this angle right here. The opposite to this angle is this x. The adjacent is the 250 meters. Right? So this equals to x over 250. And that's fortunately a simple equation to move around. So we just multiply everything by 250. We have x equals to 250 times the tangent of 75 degrees. And according to our calculator, we get 933 meters. Right, which means that this beam of light is 933 meters tall. Which I guess kind of makes sense, right? Clouds are probably a kilometer above our ground. Right? So yeah, this is how we can use diagrams to help us answer those kind of questions. And just a general rule of thumb, those tangent questions will generally have one angle that's known and one side length that's known, or two side lengths that's known. But all in all, generally in those questions, you should always know around two things. With that being said, let's do some exercises. So please pause the video here, tackle them themselves, and then unpause as we go through them in a bit. Alright, so I hope you got some time to pause the video and try them out yourselves. Let's go over them quickly. Starting with the first group, we've got three questions right here. Right, so first triangle here, we have to find G. Right, so we have the angle of 59 here, whereas this side we know is 3 centimeters. So the tangent of 59 degrees is equal to its opposite side, which is G, over 3. We do some quick rearranging to find that G is equal to 3 times the tangent of 59 degrees. which from the calculator gets us 5, right? Or 4.99, which rounds up to 5.0 meters. Okay, next question. Well, let's find little v here. Right? So looking at this little v here, we use this angle that we know, 23 degrees. Opposite is 1.2, adjacent is v. So the tangent of 23 degrees is 1.2 over v. We rearrange everything to get v times the tangent of 23 equals to 1.2, which is v equals to 1.2 divided by tangent of 23 degrees, which is 2.8 meters. Oh, I guess it's centimeters. That's my bad. Right, that will also be centimeters back there. Oh, I just absolutely destroyed here. Oops. cm. Okay, here we go. Okay, so lastly, we'll look at r here. Right, so the angle we have the information of is the 15 degrees right here. Opposite is 1.5. The adjacent is this r. So tangent of 15 degrees is the opposite, 1.5 over r. We multiply everything by r right here to get rid of the annoying fractions. Divide everything by tangent of 15 degrees to isolate, which gets us 5.6 centimeters. Alright, so all the questions are about the same. We figure out the tangent and then isolate for the side we want to know. And now here's the word problem. Base of a ladder is on level ground 1.3 meters from a wall. Right, so we have the ground here. We have a wall here. And we have a ladder right here. Okay, so it is 1.3 meters from the wall, so this distance here is 1.3 meters. And it says that it leans against the wall at the angle of 71 degrees. So this angle right here is 71 degrees. Want to find out how far up this ladder is. Right, so this is our diagram. And as a triangle, it will look something like this. So 1.3 here, 71 degrees here. Alright, so let's use tangent. The tangent of 71 degrees is the opposite, or here's x here, which is x over 1.3. Which means that x equals to tangent of 71 degrees times 1.3, which gets us 3.8 meters. Right, nearest tenth? Yes, nearest tenth. Right, which means that this ladder, if we place the ladder at 1.3 meters from the wall and lean it at 71 degrees, the ladder will go up by 3.8 meters up the wall. Alright, that's all there is to it. So I hope that you all have learned something here. So yeah, keep practicing and stay hydrated.